Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials on any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com.
All right. Thanks, Krishnamurti. Thanks, Gopi, for the confirmation. So today's session, we'll be discussing about a basic introduction to the Kubernetes, why we are using the Kubernetes, and the basically the architecture of this particular software, how it is used every day, like in production environments. So all that we will be seeing. So first of all, let's go ahead and discuss about what is the agenda for this session. Okay, so first of all, we need to understand. So first point we'll be discussing here is understanding the need of Kubernetes, right? So the first point it should be why we are using the Kubernetes at the first place. Why? What is the container orchestration? And since the Kubernetes is a container orchestration tool, but what is the container orchestration and why we require it? So all that we'll cover in the first point. After that, we'll cover the Kubernetes architecture. Then we'll look at some Kubernetes concepts, how it is what are the terminologies that are used. Then we'll see what is the difference between containers and microservices and what is the need of microservices. After that, we will throw a light on Kubernetes master components. And after that, we'll also discuss about the node components. So there are like node master component and node components are mentioned here. So we'll throw a light on that. After that, we'll also discuss about some Kubernetes add-on like DNS, Web UI, and container monitoring and cluster level logging. Yeah, so after that, we'll do some hands-on. We'll check if we'll understand what is Kubernetes pod. We'll understand what is replication controller, what is deployment service, and then we'll do some hands-on with some pods. Like we'll try to deploy some pods using the deployment. We'll see how we can scale that particular pod, and how we can work with the services and all. All right. So let's get started with our first agenda of the day. So it is container orchestration. So what is container orchestration? Okay, so if you have a basic idea about if you have an idea about your Docker or containers. Okay, so let me just briefly tell you what a container is. Okay, let me just briefly tell you what a container is. So for that, I'll require some drawing tool. Just a minute. All right. So let us first understand what do I mean by containers. Okay, so I'll briefly cover this because this is not the agenda for the day, but I'll just give a small introduction on what is containers and what is virtual machines. Virtual machines. Okay, so I'll just give a quick overview on this. So you might be, all of you might be already aware about virtual machines, like how they run and what are the virtual machines. So it is quite a very straightforward concept for the virtual machines. So what we do, we have one physical host. Okay, we have one physical host. On top of that, okay, we install some OS. Okay, so we have one physical host. On top of that, we install some OS. OS means nothing but your operating system. Okay, once we install the OS, on top of that, we install one program called as hypervisor. Okay, so hypervisor is nothing but a program. Hypervisor is nothing but a program that emulates the behavior of virtual machine. So that means this hypervisor is useful to emulate the behavior of a virtual machine, so that when you create the virtual machine, the underlying or the application that is residing on that particular virtual machine will not understand that this particular host is not a physical server, or so that is how the hypervisor will do it. So hypervisor is a program that emulates the behavior of your virtual machine. Okay, on top of that hypervisor, so as I have mentioned, we create the virtual machine. So that is the basic architecture of your virtual machines. And on top of that, you can create as many virtual machines as you like. And inside that virtual machines, again you install some OS. Again you install some OS. All right. Again you install some OS, and on top of that you run some application code. On top of that you run some application code. Okay. Okay, so this is how a basic look or overview of a virtual machine will look like. Okay, so we have some physical host, and on top of that we are just installing OS. So this is virtual machine, and hypervisor is nothing but a program. That program can emulate a similar behavior as if this host is a physical host. And this is how, like, you can create multiple virtual machine on top of your single physical host. That was fine. Like, it was this concept is in the industry since many years. But now here we are discussing about containers. So what is the containers? Okay, so we now know, we understand what is the virtual machine, right? Now let's go ahead and understand.
Hey viewers, our Master in DevOps engineering program can help you to hone the skills necessary to succeed in high-level DevOps positions. So, what are you waiting for? Enroll now and earn certification that show you are keeping pace with today's technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
What are the container and what is the basic difference between the container? So you can think of container in containers. First of all, we are dropping this hypervisor. Okay, so we are just dropping this hypervisor. So we don't require this hypervisor inside a container. Okay, so what is container then? Okay, so you can assume like that. You can assume like that. You can assume like that. This is again your physical host. Okay, this is again your physical host. And on top of that you install some OS. So let's assume you have installed Linux OS. On top of that you can install any OS. Let's assume you have installed some OS here. Okay, so now, as I mentioned, we are dropping this hypervisor. So hypervisor was a program which was responsible to spawn up some virtual machines, and that virtual machines were then we were installing the OS in that, and then application was running. But now with this particular container orchestration, what we can do on top of this OS itself, we will use some container runtime. Okay, we will use some container runtime, container runtime container runtime. And what is this container runtime? So this container runtime is nothing but which, so you for now just think of it as something that can run the container. Okay, something that can run a container. Okay, So you can assume like that the container runtime is there, and on top of that, this container runtimes, you directly have the containers. Okay, you directly have the containers. Okay, now this containers, okay, so these containers are directly running on the base OS. Now there is a difference, the major difference between your virtual machine and the containers is, so let me name it as a container. Okay, so what is the main difference between the container? As you can see, in case of virtual machine, the OS is installed separately inside of a virtual machine. But now this particular containers does not require any OS to be installed. So it uses the kernel of your physical host itself. So that means if you are, what is kernel? Kernel is nothing but operating system itself. So let's say if you are using some Linux operating system, this container will run as a process, and this will you make use of the underlying OS itself. So you are not deploying any OS inside it. Okay, and this container are self-sufficient. They have their shared libraries, and so that every application can be containerized, and then it will be running directly on your base operating system. So here we are saving some resources by using the thing that here OS is required. So that means more resources will be required, so we are saving some resources, and also the boot time will be more here, so we are saving time also. This containers will spawn up very fast. So that's how like the things will be. So this is the basic difference between virtual machine and containers. And to summarize what a container is, so container is nothing but a Linux process. Okay, so what do I mean by a process? So process is nothing but a piece of software or piece of code that is running on your node. So it is nothing but container is Linux process. Okay. So uh, so as I have explained the basics structure about the Linux processes, like what do we call a Linux process? So when I'm saying container is a Linux process, that means this particular container is running as a process inside your operating system. And what is the process? Process is nothing but a piece of software or code that is running on your host. So you can think of it like that. When you launch some Chrome browser, so what happens? In the backend there is a one process whose name is Chrome, so that is running in the backend. So that's how uh, the containers are similar way, is a process that are running on your virtual that are running on your host. Okay, and it the basic thing is it makes use of the OS or kernel of your physical host itself, so it does not require its own operating system. It just make use of the kernel of your host OS where it is running, right? So this is the basic thing that I wanted to show you. Now the next thing is, you might have already heard about Docker. Okay, you might have already heard about Docker. So in the previous explanation, I was talking about container runtime. I was talking about container runtime. So what is this container runtime? So as I have mentioned, this container runtime is nothing but which helps in running the containers. Okay, what is this container runtime? So which helps in running the containers. Okay. Okay. So Docker is nothing but one type of container runtime software. Okay. And what is container runtime software? Which helps in running the containers. And then what is the container? Container is nothing but Linux process. And what is Linux process? Linux process.
Hey viewers, trying to get into DevSecOps? Enroll for our DevSecOps certified professional programs and earn the certification that shows you are fit for these technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Process is a piece of code or software, specifically running instance of your piece of software or a code. Okay, so let me just make it down here. So Docker is nothing but one container runtime software. And what is container runtime software? Which helps in running the containers. And what is container? Container is nothing but Linux processes. And what is Linux process? Linux process is a running instance of a piece of code or software. Okay. So what happens when you install Docker and when you try to run some containers? Okay, when you try to run some containers. So in production, what happens? Let's say if you have thousands of let's say if you need, so let's consider a classic example of Amazon's big billion sale. Okay, big billion sale. So what happens in the big billion sale? Amazon is already expecting that there will be lots of customers hitting the application URL, right? So Amazon is already expecting that thing to happen. So let's assume that Amazon is now using Docker. Amazon is using the Docker to implement the infrastructure. Now, when I'm saying they are using Docker, so Docker is nothing but a container runtime software. So they are just using Docker to manage the containers. Now in production, when I'm saying there will be lots of customer hitting the URL, so that means we need to have multiple replicas. Okay, we need to have multiple replicas of the application, right? Because there will be lots of users that will be hitting the URL, so we need to have multiple replicas of the application. But if I'm considering a production environment, so there will be if I'm considering a production environment, so all the infra will be distributed, right? All the infra should be distributed. What do I mean by infra should be distributed? That means your application is running on multiple hosts. Now you might be aware that you can manage the you can use Docker to manage the container on a host, so that Docker will be you will be only able to use that Docker to manage the containers that are running on the same host. But as I'm mentioning, it is a production environment and the containers are running on different environments. So now I have to manage it from a single place. So it will be very hectic if I go and check every node and then manage those containers. Okay, so the basic thing that I wanted to highlight is it is very difficult to manage if the containers are running on different nodes and you are just using Docker. Okay, so for that, to manage the production environment, we require some orchestration tool. Okay, and what do I mean by orchestration? So orchestration is nothing but managing the distributed Docker containers from a single place. And what things are we managing? So we are managing scale of the application. So that means, let's say if you have 50 replicas, and as per the requirement you need 500 containers replicas, so that you can do using single command from a single place. Okay, so what is the thing that I'm mentioning here is a scale. So you can scale you can scale your replicas from 50 to 500 from a single place. So that was not possible if you only use Docker. So in that way you can spawn up as many containers you want, and it will be done from a single place. Now what is the next thing that we need to check? So next thing is, as you might be aware, Docker, when you create some container, Okay, let me write it as first thing. What I mentioned is a scale. So you can mention a scale. So next thing I can mention as a networking. So what is networking? So these are the parameters that orchestration tool can be used will be using. Okay. So first thing I mentioned as a scale. So you can manage the 500 containers. Those are distributed on different nodes from a single place. Okay. Next thing is networking. So you might be aware that the Docker, when you spawn up some container, Docker will provide some networking. Docker provides networking. Okay. Or any container runtime provides networking. But now, as I'm talking, my whole environment is a distributed. So that means, what do I mean by distributed? So that means, let's say if I have multiple servers like this, okay, multiple servers like this. Now all my containers are running on different nodes, right? So what I need a connection between, like, this container should be able to talk with this one. This container should be able to talk with this one. So how do I achieve this? So if it was only the case where the Docker is running on all the nodes and then they are communicating, then that is fine. Like, Docker can provide that networking. But now, since I'm mentioning that there is a lots of distributed nodes where I'm running my application as a Docker container image or Docker container, then this particular networking of communication between node 1 or node 2, node 3, so all this communication networking, all those will be managed by your orchestration tool. Okay, so Docker provides networking, but now what you can say, network.
Hey viewers, are you looking for formal training on SRE practices? Take our SRE program. This course will teach you how to successfully implement site reliability engineering in the modern day 24/7 services. Kickstart your SRE training today. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Working on networking for the spawned container, but orchestration tool will provide networking for all of your cluster components like nodes, pods, services. So we'll be shortly seeing what this service and all means. So this is the networking. Then again, you can have different parameter like storage, managing the storage for your containerized application, and then you may also say security, like managing the security from a single place, giving the RBAC policies like role-based access. So all that can be done from a single place, and that is what a orchestration tool means. So orchestration tool can be used to scale the application, to provide the networking, to manage the storage, to provide some security. So all those things can be done using that. So we were discussing, the first point is understanding the need of Kubernetes, and for that Kubernetes is nothing but a orchestration tool. So we need to understand what is container orchestration. So as I have mentioned, container orchestration automates deployment, management, scaling, and networking of container. That means automatically the scaling, the networking, the storage management, the deployment will happen, and there will be hundred and or thousands of Linux container, and we can make use of this orchestration tool to manage all of that. Okay, now uh, once we have already seen like what is container orchestration, like I have already explained how why it is required to orchestrate the containers in the production environment. So you can think of this like that. So what is a container orchestration used for? So we have discussed some of the points from here, like provisioning and deployment. So that means when you want to, let's say, create new application, so that application should be highly available, right? So multiple replicas may be present. So using this container orchestration tool, you can create as many replicas as you want, and you can send those application in different nodes as well, right? Then you can also do the resource allocation. So what is the configuration and scheduling means? You can schedule the particular container on particular node. So let's say in your cluster you have 10 nodes and you want to schedule one particular application on one node A, let's say. So you can do that also. You can do resource allocation. So what is resource allocation? That means you can specify how much resource my container should use, how much total resource consumption should be there. Then there is a load balancing and traffic routing. So that is also part of your, you can implement different types of load balancers in your Kubernetes or orchestration tool. Okay. So these are all like some features that container orchestration is used for. And so we have already understood like what is a container orchestration. Now let's go ahead and understand what is Kubernetes. Okay, let's go ahead and understand what is Kubernetes. So what I'm trying to say is, let me just open my notepad slideshow. So we learned like what are the parameters that orchestration tool will be using, and then what is Kubernetes. Okay, what is Kubernetes? So as I mentioned, Kubernetes is nothing but an orchestration tool. Orchestration tool. So what is that? Orchestration tool. So this particular orchestration tool means it will help to manage distributed containers across the prod environment. Okay. So what is Kubernetes? Kubernetes is nothing but an orchestration tool, and it will help to manage distributed containers across your production environment. Okay. So now let's go ahead and learn our next agenda, that is Kubernetes architecture. So what is Kubernetes architecture? Let's throw some light on that. So you can see some diagram here. So the Kubernetes or architecture is broadly divided into two parts. Okay, so Kubernetes architecture is broadly divided into two parts. Okay, so what is that? So first, so this is Kubernetes architecture. So as I mentioned, it is divided into primarily divided into two parts. So first part, you can say it has a control plane. Okay, control plane. And second part you can think of as a worker plane. Okay, worker plane. So let's first understand what this control plane means. Okay, what this control plane means. Okay, so think of this like this. So you might have in the past, you might have worked on multiple tools like Ansible, Slave, and or any other tool which uses client server model. Okay, so what happens in that client server model? The server will be managing all the things for your client. I mean, when you fire some command on server, it will automatically delegate the jobs on your worker machine, something like that. So here also in Kubernetes architecture, the control plane is nothing but a set of machines. Okay, and what is the control plane? So as I have mentioned, Kubernetes architecture. So Kubernetes architecture can be divided into two parts. Okay, can be divided into two parts. The first part is nothing but your control plane, and second part is nothing but your worker plane. Okay. Now what is this control plane? This control plane is nothing but a set of machines. set of machines, or you can also call it as node. So node is nothing but your machine only, like set of machines which will be responsible to manage the cluster. Okay, to manage the cluster. Now what is the cluster? So cluster means set of nodes or machines, those are working collaboratively to provide a infrastructure platform. So what is a cluster? Cluster is nothing but a set of machines that are working together, I can say, and those will be responsible for providing you the environment, right? Now, and what is the control plane? So control plane is nothing but set of machine which will be responsible to manage the cluster. Now when I'm saying managing the cluster, so that means all the administration tasks like managing the nodes, how many nodes should be there, and then creating some resource quota, like restricting some resource uses, all those kind of things, those are required as an admin user or as a developer, will be done on control plane. Okay, so control plane is nothing but set of machine which will be responsible to manage the cluster. And now what is the worker plane? So worker plane, what is that worker plane? It is also set of machines or nodes. Okay, it is also set of machines or nodes.
Thanks for watching. Want to study further? Join our training programs today.